Hey everyone, Praveen this side. Hope you all are doing well. So today we are going to solve the problem majority element 2, which is a medium level problem. So let's read the description first. You're given an array of integer ARR where each number represents a vote to a candidate. Return the candidates that have votes greater than one third of the total votes. And if there is not a majority vote, return an empty array. So we have been given an array of integers where each number represents a vote to a candidate. Okay. Now we need to find the candidates whose votes are greater than one third of the total votes. And if there are not a majority vote, then we need to return an empty array. And there's a note point here. The answer should be returned in increasing format, that is in ascending order. So we have understood the description. Let's dive into examples. So for example 1, the array is given as 2 1 5 5 5 5 6 6 6 6, and the output is 5 and 6. The explanation says 5 and 6 occurs more than n by 3 times. And for second example, the array given is 1, 2, 3, 4, 5 and the output is an empty array. The explanation says no candidate occur more than n by 3 times. So I have just gone through example 1 and example 2. Let's consider the example 1 and find our observations. So what will be the brute force approach? We have been given with array of integers and we need to find the candidates having vote greater than n by 3. Okay. So for that we need to find the vote of individual candidates, right? So how can we quickly access the vote of individual candidates? Somehow if we store it in some container, right? And what do you think will be the most appropriate container to store the votes of each individual candidate? Yes, you are right. The hash maps. So here I have considered the hash map where the key is candidate and the value is votes, right? Because that's what we want. And I have done the pre-computation. That is, I have stored all the individual candidates' votes here, right? Now what we need to find? We need to find the candidates having vote greater than n by 3, right? Now what will be the value of n by 3? Since we have been given an array size as 10, if we divide 10 by 3 and we'll take the integer division, then the value will be 3. Right. Now we need to check for each candidate whether we are getting vote greater than 3. Okay. So we'll check for 2. The vote is 1. So we'll neglect this candidate. Then for candidate 1, again the vote is 1. So we'll neglect this candidate. But for candidate 5, the votes are 4, right? Which is greater than 3. So we'll consider this candidate. And for candidate 6, the total votes are 4, which is greater than 3, right? So we'll consider this candidate 2. So 5 and 6 are the potential candidates who have their votes greater than n by 3. So this will be the brute force approach that gets in our mind. That is, first store the votes of each candidate in a map. And after storing their votes, iterate through each entry in the map and check whether we are getting the vote greater than n by 3 or not. And if it is yes, then just consider those candidates and return them. Simple. Now, what will be the time complexity for this approach? Firstly, we have iterated this array to create this map which will take O of n, and again we have iterated this map to find the potential candidates by their votes which will eventually take O of n. So the overall time complexity for this approach will be O of n. And what will be the space complexity? Since we have used the hash map to store the entries of each candidate with their votes, the overall space complexity becomes O of n. Because in the worst case scenario, if each candidate is an individual digit, so we'll be storing each individual candidate and the map size will be equal to the size of array. So this will be the naive approach that gets in our head. But can we do something better than this? Let's figure it out. So what is the requirement? We need to find the candidates having vote greater than n by 3, right? So suppose consider this array where we have given array size as n by 12 and each element in array is evenly distributed. That is, we can see A has 4 entries, B has 4 entries, C has 4 entries. Now, can we find any potential candidate from this array? Because every candidate size is equals to n by 3. But what is our requirement? We need to find candidates having vote greater than n by 3, right? So if I manipulate the 0th index and convert it to C, now do we find any potential candidate? Yeah, because as C was exactly equals to n by 3, as soon as an entry got entered in this array, it became greater than n by 3, right? And again, if I replace this candidate by B, do we find any other potential candidate? Yes, because B was exactly equals to n by 3. But as soon as an entry got joined in there, it become greater than n by 3, right? So the main observation is for any given array of size n, there will be no more than two potential candidates, right? Because as we have seen earlier, there were evenly distributed candidates in an array in the best case scenario, right? And none of their votes was greater than n by 3. But as soon as we have included an extra candidate for C and an extra candidate for B, both B and C became the potential candidates, right? So this is the observation that the potential candidate size will always be less than or equals to 2, because in the best case scenario we can find at max two candidates, right? But in the worst case scenario we can find 0 or 1 candidate. Now since we know the potential candidates count will be less than or equals to 2, do we need to consider a map? No, right? Instead of that, we can create four variables: potential candidate 1, potential candidate 2, and the vote of candidate 1 and the vote of candidate 2. Okay, which looks similar to this, right? So by using these four variables, we can eradicate the usage of hash map. Now let's keep this observation in mind and run the example 1. So I have taken example 1 and created four variables as discussed to keep the track of two potential candidates, right? Now we'll start with index 0. The candidate at index 0 is 2. So we'll check whether the vote 1 is 0. Yeah, the vote 1 is 0. Now what does it signify? When the vote 1 is 0, that means there is no potential candidate yet. Okay, so we'll consider 2 as a potential candidate for now. So the vote will become 1 and the candidate is 2. Okay, so we'll go to index 1. Here the candidate is 1. So we'll check whether for candidate 1 the vote is 0. No, right? So we'll go to candidate 2. For candidate 2, whether the vote is 0. Yes, the vote is 0. Again it signifies the same, that is when vote is 0, the candidate is not occupied by any potential candidate. So we'll consider 1 as potential candidate for now. So the vote becomes 1 and the candidate is 1. Now for index number 2, the candidate is 5. Now we'll check whether 5 is matching with 2. No. Whether 5 is matching with 1. No. Now what does it signify? What we have assumed that candidate 2 or candidate 1 could be a potential candidate, that assumption was wrong. So what we need to do, we need to decrease both of their votes by 1. That is vote 1 will become 0 and vote 2 will become 0. And since both of their votes have become 0, then neither 2 nor 1 will be a potential candidate. So let's replace them with some arbitrary value. So candidate 1 will become 0 and candidate 2 will become 0. Okay. Now let's process index 3. At index 3, we have candidate 5. So we'll check whether the vote 1 is 0. Yes, the vote 1 is 0. That means 5 could be one of the potential candidates. So we'll again increment its vote by 1 and the candidate will be 5. Okay. So now we'll go to index number 4. Now here the candidate is 5. So we'll check whether it is matching with candidate 1. Yes. So we'll increment its vote by 1. Then it becomes 2. And again for index 5, the candidate is 5. Okay. So we'll check whether 5 is matching with candidate 1. Yes. So again we'll increment its vote by 1. That is it becomes 3. Okay. Now for index 6, the potential candidate is 6. Okay. Now we'll check whether the 6 is matching with candidate 1. No. But for candidate 2, the vote is 0, right? So this space has not been occupied by any potential candidate. So we'll assign candidate 2 as 6 and keep their vote as 1. Okay? Assuming that this candidate could turn out to be a potential candidate. Now, for index 7, the candidate is 6. Again, we'll check whether it is matching with candidate 1. No. Is it matching with candidate 2? Yes. So we'll increment its vote. Then it becomes 2. And for index 8, the candidate is 6, which is matching with candidate 2. So we'll increment its vote by 1. Then it becomes 3. And finally, for index 9, again the candidate is 6. So we'll increment its vote by 1. Then it becomes 4. Okay. So here we have got candidate 1 as 5 and candidate 2 as 6. Now these could be the potential candidates. Remember, I have always used the term potential candidates, not the true candidates. Right? So again, we'll reset this votes 1 and votes 2 to 0, checking that whether this candidate 1 and candidate 2 are true potential candidates or not. Okay, so again we'll iterate through each element in an array. So we have changed vote 1 and vote 2 be 0 because these were just the potential candidates. These are not the actual candidates. Now we'll preserve this candidate's value and check their votes again. So we'll go to index 1 whether it's matching with any of the candidates. So again we'll start from index 0 and check whether it is matching with a candidate. No. And again for 1, no. For index 2 the element is 5, so the vote becomes 1. For index 3 it's matching with candidate 1, so the vote becomes 2. For index 4 it's matching with candidate 1, so the vote becomes 3. For index 5 it's matching with candidate 1, so the vote will become 4. And for index 6 it's matching with candidate 6, the vote becomes 1. For index 7 the candidate is 6, it's matching with candidate 2, again the vote will become 2. For candidate 8 it's matching with candidate 2, so the vote will become 3. And finally for index 9 again it's matching with candidate 2, then it becomes 4. So from what was the threshold value that we have been given with n by 3? Now here the n value is 10, right? So what will be the value of 10 by 3? It will be 3. So we need to check whether candidate 1's vote is greater than 3. Yes. Candidate's 2 vote is greater than 3. Yes. So candidate 1 and candidate 2 both are true actual candidates. So we can conclude that candidate 1 and candidate 2 both having the vote greater than the threshold that we have been given with and are true candidates. Okay. So in the first iteration, we have assumed them to be true potential candidate. But in the second iteration, what we did is we have considered the candidates same but have resetted their values to but have resetted their votes to 0. Why? Because they are potential candidate for now. How we have seen for 2 and 1 to be potential candidate. But as we have seen, when we were moving forward, 2 and 1 that we assumed to be potential candidate have turned out to be not a potential candidate. So to double cross check whether 5 and 6 are potential candidate or not, we are iterating it again. And finally, if 5 and 6 are actual potential candidates, then we'll be getting both of their votes greater than the threshold vote. So this is the complete dry run. So I want you guys to consider other few examples and dry run it by yourself, because till you don't dry run it by yourself, you will just memorize it. You will not understand it. The main intention is to understand the logic, not to memorize, right? So now let's get into code and understand it. So this is the code in C++, although the logic remains same. So here we have given a function find majority where the parameter is array, and here we need to return true potential arrays. So firstly I have taken array size and I have created 4 variables. Okay, this this was step number 1 for what we have discussed. Okay, so here I'm looping through each array element and finding whether it is matching with first candidate. If yes, then increment its count. Whether it is matching with second candidate, then increment its count. And when the count is 0, that means that candidate have not been considered. So we'll consider it as potential candidate, that it might be one of the candidates. So we'll assign that to num1 and assign the count to 1. And same with the count to, if its value is 0, it means that candidate have not been considered. So here too we are considering it to be potential candidate and assigning the count as 1. And if none of this case has occurred, that means it is not matching with num1, not matching with num2, and both of them were occupied. It signifies what we have assumed is false. So we'll decrement both of their count. Okay. So this is step number 1. So here we'll move to step number 2. Here as discussed, they have reset the count 1 and count 2 to 0. But the num1 and num2 that we have considered to be potential candidate, we are cross checking it. So we are looping in the array and checking whether it is matching with number 1. If yes, incrementing its count. And same for candidate 2, whether is it matching with candidate 2. If yes, then increment its count. And after executing this loop, I've taken a result vector and checking whether count 1 is greater than n by 3. That is, after even after cross checking, if you are getting count 1 as n by 3, then it is a true candidate. So I am pushing in result that candidate 1. And same with candidates 2 count, that is, if its count is greater than n by 3, then that is a true candidate. Okay. And since in description we have seen that we need to return the answer in ascending order, so I've sorted this and returned the answer. So this was the two-step process that we have done. Now, what will be the time complexity for this? Here we are looping through each array element, and same with here. And here we are sorting the array. But as discussed, the true potential candidates will not be greater than true. So sorting for two elements will be considered as O of 1. So the overall time complexity becomes O of n. And what will be the space complexity for this? Since that's what we were trying to optimize, right? The space complexity will be O of 1 because we have just created four variables which was acting just like map, but handling it was pretty trivial, right? So the overall space complexity will be O of 1. So this way we have optimized our space. So I hope you guys like this video. I know it was little overwhelming. It was not that intuitive. It was purely based on observations. But if you try to solve similar type of problems, you will get it. So if you have liked this video, like, share and subscribe. If you have any doubt at any point, post it in comment. I'll try to respond it as quickly as possible. And if you have any feedback in my teaching, please post that in comment too. I'll try to work on it. So let's meet tomorrow solving any other problem. Till then, stay safe, stay healthy, and peace.